Hello, everybody. Thank you very much for the warm welcome. So, a couple of words about me. So, Carmen already said, so my name is Igor Jancev. I was born here in Sarajevo many years ago. I had like a happy teenager life until the war started. And then I found myself as a refugee in Austria. So I learned German as fast as I could, and I continued my study of computer science at the Technical University in Vienna, finished the studies, and since then I work as a software developer, engineer, architect, whatever. And the first 10 years I worked as a Java developer, and then I became Java architect. And then I heard about this new web framework called Ruby on Rails, and that you can do like a blog in an afternoon. And so I decided to try it out. And so I played with it at home, and I liked what I see. And the problem was that my job as a Java architect somehow wasn't so fun anymore, because I was just frustrated how simple and fast things I can do things with Ruby on Rails. And then I go to the job, and then I have to fight some XML, huge XML files and configurations and everything. So basically, Ruby destroyed my career as a Java architect, because I just thought, okay, I cannot do it anymore, like full time. So I thought about wouldn't it be nice if I could program Ruby and Ruby on Rails for living, not just for fun and for side projects. And at that time, there were not so many Ruby on Rails projects. So I did some smaller stuff, but then after some time, I heard about the Technical University in Vienna is searching for developers with Java and Ruby experience. And I said, okay, maybe it's not so bad, could do half-half. And then I joined this project, and that it turned out that it's they use Java and Ruby, but they need me only for Ruby stuff. So it was even better. So I could program 100% time only Ruby and Ruby on Rails. So it was the dream came true. So I could be paid for programming Ruby on Rails. And so 10 years fast forward. So I'm actually I did all of this like a freelance developer. And 2 years ago I moved with my wife to Sweden. And there we founded a small company called MasteryBits.com, and I'm the software developer in the company. My wife is product designer, so the creative force, so to say. And yeah, so in case you visit Sweden, you could see us maybe at some midsummer festival with flowers in the hair, or you could see me in some park doing my Falun Gong meditation. That's what I do for more than 20 years when I want to relax. And it's an ancient Chinese meditation practice, self-improvement practice. So let's start. So today I will talk about the campus software of the Technical University of Vienna. From the outside, it looks like one application, but actually it's one Ruby on Rails monolith and 4 Java applications. And they communicate with each other with HTTP APIs, and this is the internal part. But then there are other applications, SAP and some call managers and data warehouse. So we have to exchange data with many other systems as well. And I looked up the first commit was made in February 2008. It was Rails 2.0. And I joined the project in 2013. And Now we are a team of 7 Ruby developers, and there are a couple of other teams like Java developers as well. So today I would like to talk. I thought there are a lot of things I could share in 10 years, like you work on many things. So I choose a couple of things that I think are interesting maybe for other projects as well, like not very specific stuff that's only interesting for us. So the first one is like batch jobs. So like this is a special form of background jobs that we have. We have background jobs like sending emails and like some small stuff, but we also have some jobs, for example, for this data exchange with other systems. Like sometimes we have to generate some huge XML or JSON files, or we have to process data like daily, multiple times a day, like to import and synchronize data with SAP. And many other stuff as well, like when some deadlines for applications end, then you have to change some states. So and so we used Rescue for many years, and now currently we are in the process of migrating to Sidekick. And I worked on this actually like I started like once the migration, but then I made a mistake. I wanted to do it all at once, like to refactor the code and migrate all the data and everything. And so it was like too complicated. But then in the second try, like now we do it in parallel. So we have the old system with the Rescue batch jobs, and I established the new system with this Sidekick and also the new base classes and everything. And so now we are migrating like one job after another. So this is like a part of this UI for this new batch jobs. Like you have batch jobs, the categories, and some scheduling stuff. You can activate, deactivate. You can start a batch job directly with mouse click and see some progress. And if you click like on some details of a batch job, then you can see these, I call them job runs, like how long it take, did it fail or is successful. And if I click on details of a job run, then I see some like logs that were created. So it's actually simple, like job run log, and then in the job, the name of the class is saved. That is the actual application job that is doing the work. And this is basically how such a batch job looks like. So it's relatively simple for what it does. So it's has just a perform method and some logging statement that look like Rails logging, but actually they log in the database. If they are started with perform later, if they are started with perform now, they'll just log to the Rails Rails console. So, and you can say with total and add, you can like deliver information how many items it is processing and where the job is at the time, and then this is displayed in this progress bar basically. And so when I worked on this, I thought about what would be the ideal. How do I want the batch job to look like? So it hides most of these things like creating job run and writing to database or whatever. The job should look like as simple as possible, so it looks like if it's not using the database or anything at all. So this complexity actually hide it in the base classes. Like application job is the base class for all of the background jobs, and I often use like this around perform methods, like where you can say, okay, before the perform method is called, then like the progress bar is refreshed and some start time is saved and exception handling is here, and at the end, like we save duration and refresh and everything. So, and you see the yield, that's where actually the perform method is called from the job. And then we have this batch job, that's a subclass of application job. And this is the one that saves to the database. That's the GUI that I showed you. And then here it's again around perform, which like takes the scheduling and initializes this job run and finishes it, or writes the exception logs and so on. So it basically like all of this setup and is in the base classes, and when you write batch jobs, you just concentrate on the concrete stuff that you want to do. And so the other thing is interesting now that we use Turbo, Hotwire Turbo. Like before, we used some JavaScript for this like progress bar, and now actually there is a method like in the base class is refresh GUI progress bar that like when this progress bar is shown, it's only a partial, and then when I say I'm at 20% or 30%, it's just broadcasts this progress to the page that has this progress stream. So the nice thing about this is I can start the job in the Rails console, for example, and it's if you have the page open, you just see the progress running, or multiple people have to open the page. And there was one like hack, a small hack that I had to do, because like if the job sends these updates very often, like maybe it takes only a couple of milliseconds to progress one item, then I would bombard the clients with broadcast messages like very often. So by using this Rails cache with like it expires in 1 second, you can basically throttle this broadcast to it happens only maximum once a second, because if this provider job ID it's unique for all jobs. If it's in the cache, it doesn't do nothing, and if it's not in the cache, then it sends refresh. So it's a simple trick to do the throttling of these broadcast messages. So now there is a special form of these background jobs that we use, because we have like some jobs that process like, I don't know, tens of thousands of students and do something with them, like synchronize data. So each of the processing items are independent of each other. So it offers itself to be parallelized. So first I had one where I programmed it, like thought how could it be done, like to have a main job and then to have like a sub job, and then to slice the IDs of the students and then give each sub job like a part of it, and then like start them with Sidekick, like each runs in one thread and they do all in parallel, and then when they finish, like then the whole job is finished. So for this I created this parallel job processor, is it called, so that we need this kind of system in multiple places. So it's basically only a couple of lines of code, like I just create this parallel job processor with some name, and then I slice these IDs, so usually these are some IDs, and then I add like these sub jobs with this slice, and then I say to this parallel job processor perform, and then I don't have to know how it's like internally implemented. So the code for all of these batch jobs that use this parallelization is then very simple. And it's only how this sub job looks like. It just uses some methods like item process, so it can tell the job processor that it finished this one student. And so this perform method of this parallel job processor, it basically has the list of these sub jobs. What it does is it creates a Redis unique Redis channel name, and then it starts each job. It gives them this Redis channel, and then subscribes to this Redis channel and listens to the messages of these sub jobs. And they could send like log messages, or say I finished one item, or there's an error or whatever. And then so this main job is basically listening to these messages, writes to log. So from the outside on our batch job GUI, you don't see that it's a parallelized job. It just seems like a normal job. And then when all the jobs complete, then just say Redis unsubscribe and it's finished. And this, like, it's simple, like these parallel jobs, like they just say Redis publish, and there are simple JSON messages actually, like, that only say what type of the message it is, like completed or processed or whatever. Yeah, and then there is a special case of this parallel job processor for, like, sometimes we create these huge files, as I said, like you don't just process items, but you have to create like a big JSON file with like all applications or whatever, like in this example. And so for this, I have like a parallel file generator that you can tell, okay, this is the file name I want to have. And then these are like the sub jobs, and then the sub jobs create like only a part of the file, and then this parallel file generator that like merges all these parts into one file, and you can specify delimiter and like prefix, postfix, so you have like can configure a little bit the file. Okay, so that was like our batch job infrastructure that we use. The next thing I would like to talk is like how we create our API documentation, because we have, as I said, we have like one Ruby on Rails monolith and multiple Java applications. And we have like more than 200 some API methods and also API methods from these other applications. And they have different types and they have different versions and deprecating and whatever. So we wanted to have them all in one place. And so I thought, what do I want, like, look as an end user, like what should the API documentation look like? What do I want to have in this API documentation? And from the other side, like on the left side, how do I want to write this data for the API documentation? So it should be more near to the code, so I don't have to write it somewhere else or in some different file. So basically, I came with some simple Ruby class methods like API doc with short description, long description, so like specifying the parameters and the errors that the method can have. And from this information, then like this API documentation with different categories and stuff is created with example. Well, what I wanted to have is like example URL for this API, and also like some statistical data, like when was the last time this API was called, and what's the response time, and also what makes it easier to work with it is to find to have like the Ruby controller and method in the documentation, so it's only for administrators, so I can just copy it and I can go directly to the code. So the implementation is actually fairly simple. I mean, it was like implemented it like almost 10 years ago, I think, or something like that, like 2015. And I used like two Ruby callbacks, like inherited and method edit and class variables. And that's actually all. Like there is a module that is extended in this base controller. And how it works is like I have class variable called last API doc. And this is basically a hash of hashes where I save like the information that's provided here, like short description, response, parameters, errors, and so on. So because when Ruby loads the classes and the methods, then it loads them one by one, and then when I load a class, then inherited callback is called. Then I set back to nil some of these like category and type and whatever. And then these methods are called like this API doc, API parameter, and so on. And these methods basically save the data in this last API doc. And then when the method edit is called, that's basically after all of these annotations, then comes the method. Then I just take this data from this last API doc and save it into some nice Ruby object, like this API method, where I have like all the information I need, and then I have list. It's added to the list, and then I have a list of these API methods, and this is used by the to generate the HTML view. So it's actually relatively simple code, and if someone has to add something to this or debug or whatever, it's easy to find. So and it works like since 9 years. So maybe if I would do it today, like maybe I would look to have less class variables, maybe pack it to something else, but it's implementation details. What's important for me is like actually how this looks from the outside, because this is where most of the work happens and it should work. And how it's implemented inside, it could be a little bit nicer, but it works like this. Yeah, and then we have this base controller where like on every API call, this again, this around action that like saves this duration and saves the information to the database from the request. And there is some extra code. I don't have time to show it now, but like as you see, you don't have to specify here this URL, like the root. So the application itself gets from the root information from Rails, and from the method and the class, it can like find out which root is it. So I can show it here in the documentation. Yeah, and so nice actually features that when you implement it yourself and don't use like some gem or generate some XML file and that is like shown externally in this API documentation, when you have this data, like it was very easy to integrate this API documentation from Java applications, for example, because they generate something called WADL files, Web Application Description Language. So it's XML file, and then basically I had to write a parser, like maybe 70, 80 lines of code, parse this data, create this API method objects, and so I had them in our view. So that was actually all. Or for example, this API log, it turned out we can use it for automated API tests, because if we save the like URLs for each API that is called, then I can take this, generate like a file, and then I have a test that can take these URLs and like do some automated testing. Yeah. So the next thing I would like to talk about is like developer UI. Just have to check what. Okay. Like developer UI. So we use, as everybody else probably, like we use Rake for like many tasks that are repetitive for one-off. And with Rake, like we have like now more than 160 Rake tasks, and it's sometimes difficult to find what you search for, and it loads the whole Race environment, so it takes a little bit time. I discovered actually like a couple of months ago, I discovered a gem from Shopify. It's called CLI UI. So it helps to create like more nice UI for command line tools. And it's very simple. You can read the documentation. So it offers like text formatting, progress bars, like you can run some task in parallel and then you see it. So I created something like that for some tasks that we use more often in our application. Like it's called RTIS from RubyTIS. So when you start it like with RTIS UI, then you get like a list of tasks that you can perform, and then you can like navigate the list with the arrow keys, so you can print say F, and then you can filter the list. And then when you start it, then you can have like this, like not a lot of output, but just to show you like with some icons, what is it doing right now, or use some progress bars for like downloading a file or something like this. And so I created basically as like base class for this task, for these CLI tasks. So one task looks like this, like it's, you can specify the description, and then you have perform method, and then you can use some of these like helper methods from the base class to do like to do this stuff. And one feature that we also needed, because the one thing is with CLI UI, you can do it. You can like have interactive. Like ask the user for some information and then run the code. But sometimes you, of course, need in like continuous integration, or in some scripts, you just want to run the task with options like we do with like Rails. And so I use basically Tor and this CLI UI for this. So to generate like there are two tasks like artis UI for this UI method and artis exec, where I can directly execute a task. And so the Tor generates basically then the information, and if you have some options, then you can see the options in the that you can use. And like it was like you can specify the options like with a simple method that, and then in the perform method, I just ask if the option is here, then use it, otherwise ask the user. So it's like a, and this is basically all the code you need for this to work, like have the list of these tasks, and then like this first answer, and then basically just using the list of the tasks to generate this list of options that you can invoke. And like the second subcommand, this is this artis exec, where it's generating like this executable like tasks for Tor. So it's not much code, and it adds some user like it's nicer user interface for developers as well. Yes, on the last thing I would like to mention, I didn't have time to search for. There was a blog post like many years ago that I read, that you can actually when you do Rails migrations, like before, when we were migrating from Rails 2 to Rails 3, we had a branch, and then we had some changes there, and different gems and code, and sometimes it took months, especially like this change from Rails 2 to 3 with the MERB and everything. So you would have some maybe conflicts and everything. And there's actually a method where you can use the same branch and run it with two different Rails versions. So it works. It's very simple. You create symbolic link, like for example called gemfile.next. And then in the gem file, you have a next method where you ask, it basically only checks if the name of the file is gemfile.next, then it's the next version. Otherwise, it's the current version. And so when you start with bundle gemfile is gemfile next, for example, you run Rails server or bundle install, then you run it with next is true. And so you can, in your gem file, you can say if next, then use Rails like 6.1, and otherwise use Rails 5.2. And for the code, we just have another method like in, I think it's boot RB, where you also ask if this gem file is gem file next. So in case you need different code for the different Rails versions, then you can like say if next version, then do something else, otherwise do this. So in this way, you can just say you have the same like a branch and just start it with Rails 5 and Rails 6 or Rails 6, Rails 7, and it works. Yeah, so this is just like what we talked about until what I learned, some of the things I learned, basically like to do like big migrations, to establish like the old and the new system in the application, and then to move like batch jobs, for example, like one by one, so you don't have a stress and you have to do it all at once. To start always like with this end product, how I want to the API to look like from the user perspective, the GUI or the API, or how would I like to communicate with command line tools, and then search for ways to implement it in this simple API from the outside. So to try to hide the complexity in the base classes and try to make this API as simple as possible. Yeah, and there is a lot of stuff that Ruby and Ruby on Rails offer us, like these callbacks and stuff, so you don't have to always reach for some gems and add more and more dependencies. Like many of the things, like this API documentation is not so much code, and it saves that it's our code, so it's easy to change, to migrate. So sometimes you don't need to like reach for some more complicated stuff. Yeah, so that's basically it for today. So thank you very much.